what we are going to do is we are going to try to understand what are sound waves and how do we convert an audio wave, which is a analog wave, to a digital wave, and then convert them into features, which later on we can use into uh, the audio transcription task or any of the audio classification, verification, diarization tasks. So the whole video is based upon uh, how do we try to convert an audio signal, which will be an analog signal, into the digital signal, and then how do we pre-process that digital signal to uh, the form that our modern machine learning models expect. So let's start with the basics, and there are few terms that we would like to understand. For instance, so this specific thing is a capital T. It is called as period. The distance between two highs or two lows can be considered as a period. Okay, so that's one thing. One more thing that we need to understand is this specific thing here is amplitude. This is your amplitude. Okay. Uh, After this, what we need to also understand is what is frequency. The formula for frequency is 1 upon time period. Okay. So 1 upon t will basically give you what we call frequency. And there is one more thing called as phase. Phase. So let's try to understand what is phase. Basically, the difference between these two lines is what you will call as phase. The difference between this low and this low is your wave. Sorry, phase. Okay, so phase, it enables you to shift your waveform, and the position of the waveform at time zero is what you can call as phase. Okay, so that's your phase. First one, uh, in terms of frequency and amplitude, higher the frequency is basically higher your sound. Second, larger the amplitude, louder is the noise or sound. Okay, so louder it is. So these are few things that you should look after. And uh, pitch, again, there is something called as pitch. Uh, for you to understand what is pitch, just try to memorize this thing that pitch is nothing but it's a logarithmic way of defining frequency. So when you define frequency in a logarithmic way, you call it a pitch. All right. Uh, okay. So these are few jargons that you guys would keep handy while uh, we move on to the next phase, which is where actual uh, mental model will fit in for how do we transform audio to a feature. And let's try to do that. Let's try to understand that. I would like to break it down into three things. First, okay, so there are three steps for you to. So you guys must have heard about Mel-Spectogram or logarithmic Mel. So for you to come to that stage, there are few prerequisites. We would see how those prerequisites uh, fall into their places, but there are three steps. Basically, first step is where you calculate uh, a time related, you create a graph which presents your sound in terms of time. So there would be amplitude on y-axis and x-axis will be your time. So you basically represent your audio in time. Okay. Second thing is where you represent your audio in terms of frequency. Okay. And then again, there are few things that you guys should know. We'll go into this in uh we'll reach a certain depth of the understanding of how do you represent your audio in time or in terms of frequency, but that will be for later part of video. Right now, the intuition is as simple as you represent your audio in terms of time, then you represent your audio in terms of frequency. Again, how do you convert that time representation of audio to frequency representation of audio? That's something which is, so let's say this is your time representation of audio. This is your time representation of audio, and this is your frequency representation of your audio. Okay, and for that, we'll give a yellow. So, all right, and the time representation to frequency representation, this thing is done using something called as Fourier transform. Okay, something called as Fourier transform. So if you have a representation of audio in terms of time, you can create a representation of audio in terms of frequency using something called as Fourier transform. Okay. And then again, we'll go into the depths of how do we apply Fourier transform, what is Fourier transform, would like to understand the mathematical intuition of what Fourier transform is and how do we apply it. So we'll try to scratch it, but not in this video. This video is just for the conceptual clearance of few jargons that we'll be using. So yes, continuing to the prerequisites that we had. First is we have representation of audio in terms of time, and from that itself we get representation of audio in terms of frequency. Now, when you want both the things together, you want time and frequency together, that's where the Mel-Spectogram comes into play. So when you have time and frequency representation of audio, Yeah, when you have representation of audio in terms of time and frequency together, that is called as Mel-Spectogram. Okay, this is the basic intuition. Uh, Now, for this video, we'll try to stop here. In the future videos, what we'll try to do is we'll try to understand how the audio is represented in terms of time. Then, what is Fourier transform? How do you apply that to the audio representation in time so that you can get the audio representation and frequency? And lastly, we'll try to understand how time and frequency together would create a Mel spectrogram. So that's how it's gonna be. But for now, that's it. Later on, what you would know is that Mel spectrogram is something which is an input to your uh, the black box of the model where all the audio classification, speaker verification, all these things are done. So that's it for this video. See you in the next.